Okay, so this is 10.1 properties of dilation. So it's still some transformations here that we're doing with figures, and your objective to be able to describe the properties of dilation. Dilation is basically when you transform a figure and you move it from one point along the ray. So basically, in this case, we have this one, and we're enlarging it along those rays. Okay, through that point, through the point of the center of dilation. Okay, so we're going here, and so we're enlarging that. In that case, if we were to shrink it, we'll go this way. Okay, so that's basically dilation, making it smaller or bigger. You want to put it in that sense. Okay, and it has a common scale factor, so we'll talk about that over here. And then center of dilation, again, is basically a fixed point. So this point right here, where the vertices of the shape of the image and the image connect. Okay, so if I were to go from here to here, you know, this is where everything connects, right here. Okay, so that's the center of dilation. Vertices of dilation basically are this right here. Okay, so those are your vertices of dilation. They're located along the lines. Okay, and they connect the corresponding parts of the figure that are intersecting. Enlarging is making it bigger. Think about large, and then reduction, making it smaller. And then you have a scale factor, so basically the ratio that you use to either enlarge it or to shrink it, okay, to reduce the image. Okay, so let's just quickly go look at this one really quick to see the properties of dilation, and then we'll go over how to find the scale factor, and then I'll show you how to find the new order pairs when you're given it on a graph. So in this case, these two triangles aren't the same shape, so then the shape is preserved. The size, of course, not, because that's what is either being shrunk or being enlarged. So this one doesn't preserve the size. And that, remember that for to think about congruence, okay? Because remember, congruence has to do with shape and size being the same. So in this case, they are not going to be congruent. Orientation, they're facing the same way, so that one's preserved. And then we have angle congruence. Okay, so corresponding angles, so like this angle equals that angle equals this angle, and the angle is going to be equal to the angle. And then proportionality of sides. So again, the sides of the figure are not going to be the same. Either they're going to be smaller or bigger, but they're proportionally bigger or smaller. Okay, so we'll go over that over here. We actually go over this connected to this. So let me draw something on the graph. Okay, so let's look at these two shapes. So we have the pre-image and the image. So it's that dilation, and just kind of going over the vocabulary. If I were to grab a ruler and go here, let me just quickly show you. If I were to grab a ruler, I'm not gonna do it through because I don't want to ruin my triangles, but if I were to do this, I messed a little bit, I messed it up over here, but anyways, that would be my dilation from here to here. It's a reduction because I'm making it smaller. This will be my center of dilation, and then this will be my vertices right here of dilation. Okay, and then let's find the scale factor. Okay, so to find the scale factor, I can either take the ratio of the image over the image of each of the sides. Okay, so let's do that right here. Okay, so let's take the ratio of the image over the pre-image. Okay, so we have my images, this one, so let's do AC. So side AC is 2 units, and this is a prime, so that's and then let's do AB. A prime, B prime equals also 2 units. I'm not gonna do this one because it's gonna be a decimal, so I'm just gonna keep it like that for now. And then right here for my pre-image, I have AC, which is 1, 2, 3, 4 units. And then AB, side AB is 1, 2, 3, 4 units. And it's asking me to go from image to pre-image. So this is my image, so I'm gonna say 2 over, and the image is 4 units for this one, right? So there's one for this one, and then for this one, I also have 2 over 4. And if I make that in the simplest form, if I ran the simplest form, is 1/2. So in this case, the scale factor is 1/2. When the scale factor is less than 1, that's gonna be a reduction. If it's greater than 1, it's gonna be an enlargement. You're making it smaller, you're making it bigger. Okay, let me show you another one really quick. Okay, so this one right here, the other way to find the scale factor is by doing the scale factor of the coordinates, the x and the y. So use the same one that you did it here. So what I'm gonna do is I'm gonna take my a prime, b prime, and c prime coordinate, and I'll do my a, b, and c over here. Okay, so in this case, that's 3, 2. Then I have 3, 4. And then I have 5, 2. And then on this one I have 6, 4. And then I have 6, 8. And then I have 10, 4. Okay, so let's look at this ones first. Okay, I'm gonna do my x prime over my x. So x prime is 3 over my x is 6, and that reduces to 1/2. Okay, I can do it with the y as well. My y prime is 2 and my y is 4 right here, so that's also 1/2. So you can do that to each one of them, and you're gonna end up with the same scale factor. Okay, just like we did when we did the measurement of the sides. You can do that, and right away you're gonna get the same scale factor. Okay, so let me go ahead and give you one to do. So you're going from this pre-image to that image. Go ahead and give me the scale factor. For this one, remember, you can either take the image over the pre-image, one side will suffice, or you can just take the x prime over the x or the y prime over the y, and that will give you the scale factor. Okay, I'm gonna give you another one, but this one I'm not gonna graph it for you. I'm gonna actually just give you some order pairs, and you're gonna have to find the scale factor for me. Okay, so go ahead and give me the scale factor for this one. And go ahead and give me the scale factor for this one again. Make sure that you use this formula to figure out your scale factor. Okay, and one more last thing. So finding the new order pairs. So for instance, if we say without doing the graph, right? If I just said that there's a triangle with those vertices located on the coordinate plane, and I need to find the new order pairs. So this is a scale factor of 3. That means I'm gonna multiply each one of those numbers by 3, and that will give me the new order pairs, and then I can graph from there. So then 3 times 1 is 3, and 3 times 3 is 9. So that's my new one. Where let's just call that A, and this is gonna be A prime, and then call it B and C. 2 times 3 is 6. 7 times 3 is 21, so that will be my B prime. And then lastly, I have negative 1 times 3, that's negative 3, comma, negative 3 times 3 is negative 9, and that will be my C prime. Okay? So let me go ahead and give you a new factor, and you're going to give me the new order pairs. So give me the new order pairs for A prime, B prime, and C prime. Same order pairs for the pre-image, but different scale factor. Okay, this one scale factor is going to be half. So let me go ahead and take the same order pairs here. So if I'm doing a scale factor of 1/2, I'm going to say 1 times 1/2 is just 1/2. And then 3 times 1/2 is 1.5, 1.5. So let me go ahead and put it in decimal form. So 0.5, comma, 1.5. And then half of 2 is 1, half of 7 is 3.5. Half of negative 1 is negative 0.5, negative half, and that half of that is negative 1.5. Okay, so that's all you have to do, and then graph. Okay, let me go ahead and give you a different scale factor for this one. Okay, so go ahead and give me A prime, B prime, C prime with that scale factor. Alright, God bless you. Bye.